In this video, we're going to refresh your memory on dividing polynomials and finding roots. Okay, so at the top here, when dividing polynomials, it is always possible to use long division. You can always use long division. And then synthetic division is most efficient when dividing by a linear factor. Okay, so look at our two examples. Guess what we're going to do? We'll do synthetic division, and then we'll turn around and do long division. One thing, and I write my lines a little bit differently than I see books, but whatever. Well, notice in here that we have 0 x cubed terms. So if you lose that, everything's going to be wrong, so don't lose it. But we're going to write down our leading coefficients. And then we put this right here. That's the factor we're dividing by. And that factor has the corresponding root of positive 5. Out here, we always write the root. Okay, so we have changed the sign on that because this is always the root. Oh, you can't see that. Root. Done. Okay, so just a quick refresher. I think you've seen this before. I write down the 1 and then I multiply. So 1 times 5 is 5. Then I add these, multiply. What is that? Oh, this is annoying. 28 times 5, well, 20 times 5 is 100. 8 times 5 is 40, so 140. 135. I don't want to do that. Why did I? Ooh, my drawer is loud. I'm going to grab a calculator. Okay, sorry. 135 times 5, and then we have to add 2. So there we go. Add 2. And what we have found here is that this quartic divided by a linear gives us, well, this becomes a cubic. Right? If I take a quartic with a degree of 4 and divide it by something with a degree of 1, then I'm now left with a cubic. And so this becomes x cubed plus 5x squared plus 28x plus 135 plus this over what we were dividing by. Because if you think about it, like back in elementary school when you learned to divide 11 by 2, well, you said, okay, this goes in there 5 times. 5 times 2 is 10. We subtract, we had 1. Well, that 1, the very beginning of division, perhaps you would write remainder 1, but it didn't take very long for you to realize, and then, oh, okay, that's 1/2. Same idea. We take this remainder and we put it over what we were dividing by. Oh, I may have encroached in my space on the next one, but let's use green because I can. Okay, so on this one, when I do long division, I like to make this very systematic. I like to keep all my columns nice and neat. So I'm going to take this 2x cubed and divide it by x squared to figure out what this first term should be. Well, that is 2x. And so I write everything in this column, it'll all be x cubes and so forth. So I even write it at the top like that. When I distribute back, I get 2x cubed plus 10x squared plus 4x. And now, just like we subtracted here, we're going to subtract here. Make it negative, make it negative, make it negative. Don't forget to distribute through. The x cubed term is gone. We now have 3x squared plus 15x plus 6. Okay, so now I'm looking at, well, 3x squared divided by x squared. That is just 3, and it's a positive 3, so we'll say plus 3, and that's in the column of the whole number, except I write bigger than I type. Okay, so then I distribute it back, and I get 3x squared plus 15x plus 6. Oh, what do you notice? Everything's the same. Subtract. I'm down to 0. So this one had no remainder. So this cubic divided by this quadratic gave me that linear function.